Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's Learn How to Sudoku, episode number 6. And this is just essentially a version where instead of, for the very easy puzzles, I'm basically going to try to do a more in-depth explanation so that people can learn how to Sudoku, essentially. Um, this is just a uh very easy puzzle for those who just want to actually just do puzzles. So anyways, on to today's puzzle. It's called Integral of X Cubed by Evan. And it's a very easy puzzle, and here are the rules. uh it doesn't say anything about normal Sudoku rules, but I'm pretty sure it requires normal Sudoku rules. So normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Renban lines. Pink lines must contain a set of consecutive digits in any order without repeats. So, for example, I see why it's the integral of x cubed, because this is the integral, this is x, and this is cubed. And this is the part that you also require for integral. You have the difference of x. I think it's what's. It's been a while since I've done this integrals, but yeah. Anyways, pink lines contains a set of consecutive digits in any order without repeats. So, for example, if this were a 9, since it has connections here, that would mean that the other 3 digits on the line would have to be 6, 7, and 8 in some order. We don't know which. So it could be something like 8, 7, 6, or something along those lines. And there cannot be repeats. And to have a set, yeah, in consecutive order, the reason why it's 9, 8, 7, 6, if you know there's a 9 on here, is that 9's only consecutive with 8, which is only consecutive with 7 and 9, and which is only consecutive with 6 and 8. So to form a consecutive set, you have to go down 9 to 8 to 7 to 6. And that's why you know 8, 7, 6 would be the other remaining ones on that Renban line. And that's how Renban lines work. Region sum lines. Digits on a blue line have an equal sum n within each box it passes through. So basically, for example, these 3 digits would have to equal the same as these 3 digits, which must be the same as the sum of these 3 digits. That's how region sum line works, which, it follows its name because it is the sum of the digits on the line for each region. German whisper line. 2 cells connected by a green line must have a difference of at least 5. Okay, hold up. I was wrong previously. This actually is this is one line here, and this is one line here. This is not a line that connects all four squares. This is a line that connects all 5 squares. So this is actually correct. But this is a line separate from this line, even though they cross. My bad. So this is an example here could be if this were 1, this would have to be 2, and if this were 9, this would have to be 8, and this would work actually, because these are separate lines here. My bad. Apologies for that. So this is a separate line, and this is a separate line. But if there were like a 9 here, then the other digits on it would have to be 8, 7, 6, and 5 in some order, because this is all one continuous line, but this is not. So this is a separate line from this. This is, again, a separate line from this. So therefore, if a 1 was here, this would have to be 6 through 9, right? because you need a difference of at least 5 between digits that are adjacent on a German whisper line. So two cells connected by a green line have a difference of at least 5. And that's how German whisper lines work. Killer cages. Digits in cages must sum to the number in the top left corner and cannot repeat. So, for example, these 3 digits must add up to 12. These 3 digits must add up to 17. These 2 must add up to 4. These 4 must add up to 17, etc., etc. Then an example that would work here is, say, 3, 4. Actually, 4 doesn't work. 3, 5, and 9. These 3 digits add up to 17, so that works there. So that's an example that does work. And that's how killer cages work. XV. Cells joined by an X or V must sum to 10, X, or 5, V. So for example, if this were a 2, this would have to be an 8 so that the 2 digits sum up to 10. And so they actually kind of work like cages, but it's specifically between 2 cells. And if this were a 1, this would have to be a 4 to basically add up to 5. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so first things first, on this Renban line, we know we have, this says 1 and 5, which means the other 3 digits must be, on the line, must be 2, 3, and 4. Because otherwise it doesn't form a consecutive set that way. So this must be 2, 3, or 4. This can't be 3. That means 6, 7, 8, and 9 must be in all the other cells. So this is 6, 7, 8, or 9. Since this is 6, 7, 8, or 9, on a German whisper line, you know that it alternates between high digits and low digits. Because the highest digit, 9, has to have a digit next to it that's 5 away. Well, what's the digits that are 5 away? It can be either 4 for low or below, or 14, which is not a digit, or above. And none of those are digits. Therefore, this must be 4 or lower. So that's one thing you know about German whispered lines, is it alternates between high and low. Therefore, this must be 1, 2, and 4, but it cannot be 3 because there's a 3 already in the box. So this is 1, 2, or 4. This can't be 1. Let's see, what else do we know? Let's see. This cannot be 1 or 8. It cannot be 4 or 5. It has to be 2 or 7 or 3 or 6. This must be a 5 because the digit must add up to 5. So that's 5. What about this? This cannot be 2, 4, and it can't have anything with 5. It could be 1, 2, 8. It cannot be 1, 3, 7 because if it's 1, 3, 7, that would eliminate both possibilities of pairs of digits that add up to 9, because it would eliminate 2, 7 and 3, 6. So 1, 3, 7 is not allowed. It could be 1, 2, and 8. No 1, 3, 7. It could be 1, 4, 6 also. What else could it be? It could be 2, 3, and it cannot be 2, 3, and 6 because again that eliminates both possibilities for the 9 killer cage here. So it cannot be 2, 4, 5 because the 5 is here. So we know then those are all the possibilities for the 11 cage. So this must be 1, and it's either 2, 8 or 4, 6. So this cannot be 1, 9. It cannot be, this is 2 or 4, and this is 2 or 4, so this cannot contain a 2 or 4. Therefore, it cannot be 2, 8, and it cannot be 4, 6. Those must be 3, 7. Since this is 3, 7, this can't be 7. So this has to be 9 with 6 or 8. Where's the 5 in column 3? It has to be here. What else? you have 4 digits adding up to 11. Well, the only combination that can add up to that way with 4 unique digits is 1, 2, 3, and 5. So this has to be 1, 2, 3, 5, which means this cannot be 1 and 9, it cannot be 2 and 8, or 3 and 7, so this must be 4 and 6. And the rest of the column must be 7, 8, or 9. So this is 7, 8, or 9, this is 7, 8, or 9. Now, this must contain 4. It must have 2 out of 7, 8, or 9 at least. So the minimum there would be 7 or 8. So therefore, this would have to be at least, well, we know there's a 5 in a 5 digit Renban line. So therefore, it can be 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, or 5, 6, 7, 8, 9. So we know there has to be a 5 in a 5-digit Renban line. So therefore, this has to contain a 5. It could be 5 with, it cannot contain a 3. It could contain 4 or 6 or 7, 8, or 9 left. So this is 5, 6, 7, 8. Yeah, 5, 6, 7, 8, or 9. This must contain 2 digits that add up to 4 must be specifically 1 and 3. 14, 2 digits adding up to 14 must be either 5 or 9 or 6 or 8. So this can't be 5, that means that can't be 9. We have 2 digits adding up to 4, so that's 1, 2, 3, and 4. This can't be 3, so this can't be 2. But this can't be 1 or 3 because we have 2 digits adding up to 13. And if you have 3 with another digit, that other digit would have to be 10, which is not a digit. So therefore, this is 4, which makes this 1. This is no longer 1 because there's a 1 in the box, so therefore this is 3, which forces this to be 1. So therefore, this can't be 1, and this can't be 3. This can't be 1 or 5. This can't be 1, and this can't be 4. So this has to be 4 and 9. It has to be with either 5 and 8 or 6 and 7, because those are the only 2 that are left now. And these can't be 4, therefore this must be 2. This can't be 2 or 4, so this must be 1. This can't be 9, therefore this can't be 5. Therefore we have a 6, 8 pair in box 8. Therefore, the rest of the box cannot contain 6 or 8, so this can't be 6 or 8, which means this can't be 5 or 7, because they add up to 13. Therefore, this must be 2 with 5 or 7. So we have 1 and 2 here for certain. That means these 4, 2 out of the digits add up to 3, which means the other 2 must add up to 14. Well, 7 would have to add, 14. Well, if you had a 7 here, you would have to have another 7 in the other cell, which would not be allowed because of normal Sudoku rules. Therefore, this must be 2 and 5, which forces this to be 7. So this can't be 5. Therefore, this is 7, which makes that a 6. Now we know that in the region sum line, the region sum must add up to 14. What are the possibilities here? You cannot have 1 and 8 because there's no 8 here. Right? Because 1, 5, and 8 add up to 14. So this cannot be 1. Since this can't be 1, and we know there's a 1 in this cage, this one has to be a 1. Now, these 2 digits add up to 10. This can't be a 4, therefore this can't be 6. So these 2 digits must add up to 9. It could be 2 and 7, that works. 4 does not work with anything here, and 8 does not work with anything here. So therefore, this must be 2. Wait, that doesn't work. Huh. That's interesting. Okay. We have a problem here then. One. Okay, did I add this up correctly? No, I did not. It's not 7. Okay, well, there's the reason. This can't be 7. This has to be 9. People are probably yelling at me for that, but anyways, yeah, this has to be 9 because it's 1, 2, and 5. That adds up to 8 plus 9. Yeah, math is hard. So this adds up to 16. Well, you can't have 1 with any digit here because that would have to be 1, 5, and 10, which is not a digit. So this can't be 1, so this is still correct. This has to be a 1 then. And this is still correct in that this cannot be a 6 because the 4 would have to be, these two digits have to add up to 10. Now, these 3 digits must add up to 16, so these 2 digits must add up to 11. 2 is no longer allowed here. If you have 4, this could be 7, right? So that does work. If you have 8, it could be 3, and that works too. So this must be only 3 or 7. And therefore, this cannot be 3 or 7 because it has to add up to 9 with this digit. And these two digits must add up to 11. These two digits must add up to 9. This is 4 and 8. These two digits must add up to 10. Therefore, this can't be 8. We have a 2, 6, 2, 6 pair in row 9. So the rest of the row cannot contain 2 or 6. Therefore, that forces this to be an 8, which makes that a 6. There's a 3 here, because it cannot be 2 anymore. So these can't be 3 either. Let's see. The 1 cannot be here because of this 1. Therefore, where is the 1 in box, in this cage, right? It cannot be this, it cannot be this, therefore it must be here. So this is a 1. Let's see, what are the rest of the numbers in row 9? It must be 7 and 9. So this is 7 or 9, this is 7 or 9. This 7 or 9 must be with a 4 or 6. And in addition, we have 5 digits that add up to 30, because this is 13 plus 17. Oh, it actually doesn't make any sense. This is 15. That's fine. Okay, never mind. This can't be 6, therefore this must be 4, which means this is 9, which makes that a 7. Therefore, we know these two digits add up to 10, because these 3 digits add up to 17, and this is 17 minus 7 is 10. I think I got that right. So the possibilities would be 1 and 9, which is not allowed, because we have a 1 and 9. 2 and 8, which is allowed. 3 and 7, which is obviously not allowed because we have a 3 and a 7, and 4 and 6, which is not allowed because we have a 4 here, so this must be 2 and 8. Therefore, since this is 2, 8, we have a 2, 8, 2, 8 pair in box 9. And we number the boxes 1, 2, 3, 4, 5, 6, 7, 8, and 9 because that's how most Western languages are read. So that's why that's the default. We have a 2, 8, 2, 8 pair in box 9. So therefore, the rest of the box cannot contain a 2 or an 8. Therefore, this must be a 5, and this must be 2 then because of that. What else is left in box 9? It has to be a 6. So this is 6. Let's see, what else are we doing? These 3 must add up to 17, so therefore these 2 add up to 11. It cannot be 2 and 9. It could be 3 and 8. It cannot be 4 and 7 because of this 4. It cannot be 5 and 6 because of this 6, so this must be 3 and 8. Well, these 3 digits must add up to 16. If you add up 2 and 3, that only adds up to 5, which would force this digit to be 11, which is not a digit. Therefore, this cannot be 3. This must be 8. This must be 3. 8 is no longer allowed here. So this is 4 or 6. This must be 7 or 9. Where is the 8 in column 7? It has to be one of these 2 cells. Since there are no repeats on a Renban line, this 8 means there's no 8 in the rest of the line. Therefore, this can't be 8. Oh, also we know that. This can't be 6 because of this 6. Where is the 6 on this Renban? Because we know we have to have a 6, because the choices are either 4, 5, 6, 7, 8, or 5, 6, 7, 8, 9. Well, the only possibility would be here. So this has to be a 6, while this is a 4. Okay. This adds up to 12. Okay, so actually we know this is 2 and 8. These 3 digits add up to 16. So this must be a 6, because these add up to 10. Since this is a 6, these 2 digits must add up to 6 also, to add up to 12 completely. Therefore, it must be 1 and 5. Because that's the only combination of 2 digits we don't have in the box that add up to 6. So this is 1 and 5, which forces this to be 7 or 9, but that can't be 9. Therefore, this must be 7, which makes this 9. So this must be a 7-8 pair then. That means there's a 7 on this line, which means the 7 cannot be in the rest of the line, so this can't be 7. So this is 5 with 4 or 9. Okay, we know this is 1 or 2. This has to be 1, 2, or 5. Well, if 1 is here, the 2 cannot be here, right? Because we know the 2 is in this column, specifically in box 3. Therefore, this can never be 1. So therefore, this is 2 or 5. What can it be consecutive with? 2 can only be consecutive with 3, so 3 has to be one of these two. 5 can only be consecutive with 4 and 6, and therefore cannot be 6. This must be 4. So therefore, this can't be 2 or 5 because we have a 2-5 pair here. So this must be 1. This cannot be 3 or 4 or 1, 5, or 6 or 2, 8, 7, or 8 because of all the pairs here. What can it be? It must be 9. So this can't be 9. This is a 1. What's the rest of this column? It must be 3, 5, and 8. So this could be, and this cannot be 3 or 5. So this must be 8, which makes this 3 and 5. This can't be 5, therefore this must be 3, which makes this 5. This can't be 6, and this is next to a 2 on a German whisper line. So this can never be 6 either, right? If it's 6, it's not 5 away from 2, so that wouldn't work. So therefore, this is 8 and 9. We have the 8, 9, 8, 9 pair in column 3 and box 1. So that means the rest of the cells in box 1 and the rest of the cells in column 3 cannot contain 8 or 9. Well, this can't contain 8, so therefore this must be 4. To add up to 10, this must be 4 and 6, which makes this 2 and 7, which does work, so this because this adds up to 16. This can't be a 4 anymore, so this must be 2. So 2 is no longer allowed on the Renban line. This again can't be 8 or 9. This can't be 8 or 9. This can't be 8, therefore that forces this to be 7, which means this can't be 7. That makes that a 6, which makes that a 7. That makes that an 8, which makes that a 9, which makes that an 8. And that works for the German whisper line, because 9 is greater than 5 away from 2, and 8 is greater than 5 away from 1. What else must this be? This must be a 4, because that's all that's left in this row. Therefore, this must be 5 and 9 to make this Renban line complete. Therefore, what's left in column 7, or column 6? It has to be 2 and 7, which means this can't be 7, therefore this is 2. That makes this a 7. Here has to be 4 and 8, so that can't be 4, therefore this is an 8, which makes that a 4. This can't be 1, so this is 5, which makes that a 1. That can't be 3, because of this 3, so this is a 7, this is a 3. And we're just doing normal Sudoku here. This has to be 1 and 9, but it can't be 1 here, so this is 9, which makes that 1. This is 2 and 6. 6 can't be here, so this is 2, and that's 6. This has to be 4 and 8. But either of them can be 4 and 8, so that's 4 and 8. This can't be 5, therefore this must be 2, which makes that 5. This 2 eliminates that 2, which makes that an 8 and 2. This can't be 2, so this must be 5, which is consecutive with a 4, so this must be 4. This can't be 5 anymore, so this is 2, which is consecutive with 3. So this is 3. This can't be 3, so that's a 4, which makes that a 3. This can't be 9, so this is 5. This can't be 5, so that's 9. And then we just do whatever's left over. This is 6. This has to be 7. This can't be 4, so it must be 8, which makes that a 4. This has to be an 8. This makes that a 9, and this is a 3. And that's how you solve that Sudoku. Yeah, pretty fun. I just woke up, so math is hard right now for me, so that's why I didn't do this well. Fun integral. It's the integral of x cubed from 1 to 5 dx. What would that be, actually? That would mean, is it 1/3 x cubed? X to the 4th power? Because if you take the derivative of 1/4 to the x power, x to the 4th power, 1/4 times x to the 4th power, if you take the derivative of that, that would be, you would put the 4 down, 4 times 1/4, so that would be 1, and then you would have x cubed with the dx. Yeah, so the integral would be 1/4 x to the 4th, so that would be 5 to the 4th minus 1 to the 4th, all divided by 4. What is that? 5 to the 4th is 5 times 5 is 25 times another 5. So 25 squared. Oh. What is 25 squared? That's 25 times 5 is 125, and then 125 times 5 is 625. So that's 625 minus 1, because 1 to the 4th power is still 1. So then that would be 624 divided by 4, which is 100. That would be 22. So therefore it's 150 and then 24, 156. So you would have the integral of x to the cube dx from 1 to 5 would be 1/4 x to the 4th power, which is 625 minus 1 divided by 4, which is 624 divided by 4, which is 156, I believe. And we do have 1, 6, and 5 a decent amount together. This is 1, 5, and 6. I don't know if we actually got a 1, 5, and 6 exactly together. Anyways, that was fun. I hope you enjoyed it. I think I did my integrals correct. As I said, it's been a while since I've done my integrals. So, and I hope you enjoyed the solve. And I hope you enjoyed learning how to Sudoku. And I'll see you next time. Take care.